Hi, this is the second section of Matthew Casey's A-Level Computer Science NEA testing. In this section, we'll be going through algorithms and processes. The first part of this is to do with the character recognition system. If I launch the interface first to give you an idea of how the interface works. This is separate from the interface shown in part 1. It pops up as such. Now this interface will allow you to scroll through images. I'll show you that data set in a second. It will allow you to test the network and run an image to produce an output. If I show you the dataset being used, is here. This was the dataset used to train the network, and images of 30 by 30 resolution grayscale are saved in the folders. I believe there are over 1,000 of these images here. They are randomly selected and brought up to the testing interface. So if we look at test 2.1, that is the test with an untrained network. So this will be used for comparisons later on. So if I show you the networks I've already prepared, so we go into, you can see there are 5 versions of the neural network here. Version 1 is completely untrained. This is when the weights and biases have been randomized, so we would expect it to get 1 in every 36 correct. So if we run the interface now, this should be running. Hold on a moment. This is running neural network version 1, as you can see there. So we run this and bring up an image and run that. We can see that, as expected, that it's fairly random in the outputs. It seems to be biased towards X's and I's. If we test it, and wait a moment, you get about 4%. I'll run that again. 4.4%, that is as expected, about 1 in 36. Now if we move on to, if we look at the cost of that network as described here, cost C0. Cost is the squared difference between the outputs produced and the target output, and it's over a range of images. I can't remember the number of images of which it's collected over, but the importance is the ratio between the decreasing cost as the network is trained. I believe it'd be over, I think 10 images, the cost is summed. So we can display it, we can view that if we go to train network. And if we run that with version 1, so the cost for that network is 5,852.2. Now, if we move on to the second test, 2.2, this will be using neural network version 2, which I've claimed is 25% trained. The training of these following networks is not 100% accurate. I mean, the final neural network that I've used was trained for a very long period of time. So to save time on these testings, I haven't fully trained them to 25%, 50%, and then 75%. But it should give you an idea of the progress that testing can make. And if you just extrapolate the pattern, you can see how it can improve. So if we run the same process with version 2. So this was trained. We'll go for cost first. So we run the same thing with version 2. So the first cost was 5,800. The cost of this network you would expect to be brought down a fair amount, 1,034. You can see it started to train. And if we run the character recognition system, we can see, okay, we seem to have a sort of bias towards 0 and 9 that can be expected in the initial stages of training when large biases are placed on certain outputs. So we may even expect a lower. Here we are, it seems to have got 0 correct. Test that again. It appears to go 0.1. So that would be expected. That is okay in these early stages of training the network. This will have been trained on very few pieces of data and appears to have got large biases in terms of certain outputs. We can see that here. I think 0 and 9 come up very frequently. But hopefully those biases will be ironed out as training increases, and we'll see a pattern of the network getting better. If we go back to the test 2.3 is exactly the same using neural network version 3, and we should see that the cost produced here is less than the cost produced by the previous one. So we run this with version 3. And bring that up and test it. Hold on a moment. That was not the right network. That was still version 2. Let me bring that up there, version 3. That comes up and we test it. We can see we're now at 12.6. So that's a nice amount of progress from the original 4%, but you can see the increase. And we can compare the costs as well. That means, just to give you an idea, so that's got G as a 6, but going through these, we're expecting to get a few more right than we have been before. If we analyze the cost again, train network with version 3. So we had 5,800, around 1,000, and that's all the way down at 335. This cost decrease is follows an exponential model, so that it gets harder and harder to decrease the cost the more you train. And if we move on, so that one was, I claimed 50% trained. I do not believe that is 50% trained, but it should show you a nice comparison between as training progresses. We're now on to test 2.4. This is with version 4 of the network, very similar to before. I've claimed 75% trained. It's just simply further trained. So we can run that same process again. If we look at the cost, so it went 5,800, 1,000, 334, and 287 there. It gets harder and harder to decrease the cost as we go on. We go to the testing interface and load up version 4. Sorry. And we test that network. So it was 12%, it went 4%, 0%, and 12%. We should see a bit more of an increase. We're now at about 23%. So as I said, these 50%, 75% trained is not 100% accurate, just due to the length of time that I left these networks training for compared to my original one. But hopefully that gives you an idea of how this is training over time. We may even start to see it getting a few of these right. Potentially not. And there you go. All right, now on to test 2.5, which is the test with a fully trained network. I've called it neural network version 5. I believe it's just called neural network. And we should be able to see a further decrease in cost, and hopefully this will be nearer the final percentage accuracy that we're looking for. So we run the cost with neural network. This is the final trained network used in the system. You can see the cost is around 60, so that's far lower than we can see there. That took a far longer amount of time to train. If we then run the character recognition system, testing interface, I forget to change the network. That's neural network. It's being loaded in there. And if we run it here, we can see if we get a new image and run that, it appears to have got that one wrong. But if we continue to go through, it starts getting more and more of these correct. Got a few wrong there, more than normal. But we can test that. So this test network, by the way, is passing 1,000 of these images, feeding it forward and comparing it to the correct output and producing the result as a percentage. So if we test that, we're at 88.4%. If we go again, $87.5. 7.7. Let's do one more. Yeah, so we can see there it's ironed out at about 88. I've seen it test up to about sort of 95, down to about 85, but it's within that range there. If we close that down and move on to test 2.6. This is similar to test 2.5 using the fully trained neural network, but we'll only be testing a single character just so that it works across all the characters. So using the same neural network, the fully trained one, we can see that in the test button section, when we test the network, that's the method of the character recognition class, there's a additional parameter, optional parameter, that is the testing character. So if we put in A there, it will do 1,000 tests of A's when we click test button. And we can see that's come out to be 100%. We would assume they'd average out at about 88%, as we saw earlier. Some higher, some lower. That was clearly a higher one. If we go for maybe a number this time, 7, and test it. That's also come out at 100%, but we'd assume there'd be some variation there.